everybody, this is Ms. Dietrich. We're looking at a sample question from the 2014 state exam. It reads, Noah wants to make the kite shown below out of cloth. He wants to determine how much cloth he needs. What is the area rounded to the nearest square centimeter of Noah's kite? The first thing you have to recognize is the fact that we really are looking at a compound figure here. We need to break the shape up into shapes that we have formulas for. You could break it up into 4 separate triangles, but I'm going to propose we break it up into 2 separate triangles. So one method is to break it up going this way. Here's one of the triangles and here's the other one. The other way we could break it up is to just break it up as triangle on the left and then triangle on the right. There's no right or wrong answer for which strategy is going to be best because they do give you the heights and the bases regardless of which direction you choose to go in. So I'm going to trace going this way. We're going to look at this triangle first as one potential strategy. And the formula for area of a triangle is half of the base times the height. Now we do know that the height, which let me underline that in red, would be right here. They're giving us that is 16 3/10. So I'm going to go ahead and plug that into the formula. Area equals half of the base we're going to figure out in a second, so let's leave a space. And we know the height is 16 3/10. Now to get the base, we would need to add this piece plus this piece. So we're going to do that now in the calculator, even though we could probably do that pretty easily even in our heads. 42 7/10 plus 22 5/10. And we get 65 2/10. The next step would be to either take half of this and then take that product and multiply it by this, or it's probably going to be easier. It's fewer buttons on the calculator if we just multiply these two numbers first, and then we'll take half of that, which is the same as dividing it by 2. So let's do that. We already have that number in there, so we're going to go ahead and hit times 16 3/10. And that number, it would be this. Now we're going to take half of that, divided by 2, equals, and we get this. So let's write down what we just did. We took this times this and got this, and then we took half of this number right here and we got this. Now we're going to leave it like that for now, but it does say round to the nearest square centimeter, so we'll deal with that at the end. Alright, now let's take a look at the other triangle. We'll call it the green triangle right here. Now remember, if I wanted to rotate this and turn it around, I could if that made you feel better. But basically when you're finding the height and the base, you want to find the two numbers that are perpendicular to each other. Now in this case, our base is going to be the same. It's still this line. So we're going to grab that from right here. That was 65 2/10. And let's look at the height. Remember, the height has to be perpendicular to the base. It has to form a 90-degree angle. So they give you that number right here. It's 16 3/10. Now really, isn't this the same exact triangle, just flipped over? Look at the numbers. They match. So that means we're just going to get the same value we had for the green triangle as we did for the blue triangle. So the only thing left we have to do is either add these two numbers together, or we can just take this number right here and multiply it by 2 because we have 2 of them. So let's do that, fewer buttons on the calculator. Alright, and we get this number. Now let's compare it to the numbers that are here because it does say round to the nearest square centimeter. So the nearest square centimeter would be right here. Let's look at our indicator number. Is that a 5 or higher? It sure is. So that means we're going to change this to a 3, making B the correct answer. Alright, hopefully you found this helpful. If you wanted to break it up into 4 separate triangles, you could have done that. You could have broken it up this way, triangle over here, and then a triangle over here. That would have worked just fine. You would have gotten the same exact value. But the way I proposed, I think would probably be the easiest, especially since the two triangles are congruent to each other.